also send you the email. The emails are containing the link for the setup of all the process control equipment. So you can access to those links. You can see all equipment. So I sent you the email. So these emails are contained as my upload for the all process control equipment. So process control equipment at the Artimosa PLC room. So I took at the last year. So all the PLC equipment set up, they are how conduct interface with the computer and details electrical wiring diagram and sounds of projects are example for the PLC. Those things I already uploaded. I sent you the email. So you link down to email and you can see the how the equipment are connection. Detail electrical connection you can view. So now that we are going through the digital signal processing system, so industrial control system, we need to there are two kinds of control: analog signal processing and digital signal processing. So analog signal processing, I have already given you the last week's lesson. So how to set up the analog, how to process the signal, and also how to interface with the equipment. Those things I have already given. Now that we are going to start the digital signal processing. So digital signal processing is we can utilize when, for example, you use a PLC system. PLC is a digital signal. And then this PLC digital signal is converted to the analog signal by the interface. So those both are the interface devices. Those interface devices are connected to the switch. Those electronic switches are connected to the motor, control circuit, and by this way we are running a control system. So in the PLC room, you can see the menus are electronic, electrical devices. They are the process control. They are for the process control. So I already taken the photograph and video wiring. You can view the both video connection. Now we are going to start the digital signal processing. So before I started the digital signal processing, the digital signal processing will involve the number system and so the text decimal system and input to the digital gate and function. So these are with DAC, ADC. So before that we are going through those digital processes, digital system. I need to review the digital theory. So digital is only two states, only one or the zero state. They can produce. So there we utilize the digital IC. So then we the CMOS, DTL, DDL, HDL, and the ECS IC. Those ICs are utilized to as a digital gate. So digital gate can be the AND gate, NAND gate, NOR gate, exclusive or OR gate. Those are the digital gates. So and the digital signal processing, etc. I give you the list of the IC utilized as a digital gate. Analog means that it's system capable of the producing and output that is a continuous variable. And digital means that the system that produces the output of the two states only. So digital got the only two states, only one and the zeros are state. So we utilize that in IC package. So IC package to perform as numerous various digital functions. So there will be CMOS, DDL, DDL, HDL, and the ECL. Analog means that it's system capable of the producing the output. There is a continuous variable. Digital is a system that produce an output of two states only. So in this case, CMOS is a complementary method outside silicon. So we can utilize the N or the P channels, MOS FET. They are the low speed and the low power consumption. DDL means the transistor logic. So they got the high speed. DDL means the diode transistor logic. So a combination of the transistor and diode to implement the required function. So we utilize the transistor and diode to get the function. And the HDM is a high threshold logic. So they got the very high noise immunity. So they can withstand the noise. So because of this one, it is suitable to use for the industrial control operation. ECM is the image data coupled logic. So they got a very short gate propagation delay time. So those are the kind of the IC utilized for the digital control system. Because the industrial process control system, we are now using a lot of the digital equipment. So this is why we can focus on the digital signal processing. So before going through the digital signal processing, I review the digital principle. So when we are using the system, most of the digital devices we apply the logic devices. Logic devices means that any possible state they can control. So there are the two kinds of logic. One is the combinational logic. Okay, another one is the sequential logic. So first is the combinational logic. So when the output can be the predicted at any time, provided inputs are known. So this means that when user know the input, when I put the input, output can be predicted. So this is all the output can be predicted at any time, provided the inputs are known. Output can be predicted at any time, provided inputs are known. So this means that when you know the input, the output can be predicted. And sequential logic means that this is introduce the concept of time and memory into system. So this is time plus memory into system. So combinational logic means that when you put the various input function, the output will be depending on the combination output is produced. But sequential logic means that it can utilize the timer function and memory function. The previous operations sequence are recognized and remember by this logic, and then the output is depending on the previous these are stores operation sequence. So also time sequence also you can utilize. So in the sequential logic we can use for the timer system, time delay system. So in the PLC you can see the time delay sequence timer. So we utilize the sequential logic system. So synchronous logic means that we utilize synchronous logic. Everything is synchronizing. It should be you work at the time. So synchronous logic we apply the master clock. Clock means the square wave generator that provides a regular timing of the clocking path. So we use the synchronous logic. So synchronous logic include the master clock square. So this is the master. This is the square wave generator. We also call the clock or square wave generator. The function is it can provide a regular timing of clocking path. Provide regular timing of clocking path. So this is for the synchronous logic system. Synchronous logic system includes the composed of the master. This is the clock. This is the square wave generator. So this square wave generator functions provide a regular timing. Regular timing means the timings are counting the timing. So depending on the timings other steps are working. So this is the clocking path produced by the synchronous logic. And another one will be the asynchronous logic. So asynchronous logic means that this is for the sequential logic system. So output event occur after the previous event is completed. This means that you want to do another step, first step must be completed. So this is a synchronous logic system. So this is we can set up the synchronous logic system to set up this chain reaction of the event. So this is synchronous logic. So this means that event occur after the previous event is completed. After the previous event is completed. So this is it's a function. So we can utilize for the chain reaction of events. So to set up chain reaction or event. This is for the asynchronous logic system. So that will be the logic will be a combinational logic and a sequential logic. So if combinational logic means that output can be predicted at any time provided that the inputs are known. Sequential logic is a die and memory, integrate the die and memory into the system. Synchronous is that we use a master, you can provide a cloud. So regular timing, synchronous logic, regular timing is provided. And synchronous logic means that this is for the output only depend on the input, the previous event. Even only after the previous event is completed, so we set up the chain reaction or event. This is for the asynchronous logic. So depending on the industrial application, you have to select the synchronous logic or the asynchronous logic. The gate. So digital, we call it digital gate or AND gate, NOR gate, NOR gate, and exclusive OR gate. So firstly we talk about the AND gate. So AND gate means that we utilize the AND. So this is the input function here. We can use the AND by this way. This is AV. So this means that we can utilize the this is battery, so A switch or the B switch. Both must be on to get the output. So that we get the output with the Z function. So we can call that truth table. Truth table is A, B, and a Z. So A0, B0, and Z0. A0, B1, Z0. A1, B0, Z0, and then A1, B1 with the Z1. So this is for the AND gate are truth table. So we have to switch on the both switch to get the output. Another one we use the OR gate. So in this case, we can utilize the AND gate for the industrial control. The startup model wiring diagram. Startup model wiring is here. So this is the input. This is start switch. Start switch, and this is auxiliary contact. And this is the stop switch. So this is a folding coil. So this is line to neutral. So in this case, you set the motor. Both start switch and stop switch must be closed to set the motor. So this is for the industrial application. So they can be similar to the AND gate application. And another one will be the OR gate system. OR gate means that anyone's we can draw the OR gate symbol like this. So this is A, this is B, output is Z. So that we can draw the electrical equivalent diagram. So two switches A and B are connected in parallel. And that they are connected to the output load. So output load will be the Z. So we can draw it here A, B, and the Z. Either A, B1, output 1. B1, output 1. Both are A, B1, output also 1. But A0, B0, output will be 0. This is this function. The function is an OR gate function. OR gate function we can also utilize for the parallel combination. So this is for the OR gate. And after that, you can also see the NOR gate. NOR gate is similar to the inverter. So input waveform is inverted by the NOR gate. So input 1, output 0, and input 0, output 1. So this is the NOR gate function. The NOR gate function you can write this is the A or Z. A0 is Z1, A1 Z0. So this is for the truth table. So we also can draw the NOR gate equivalent electrical diagram. So we can draw the electrical diagram like this. This is for the A, and this is for the relay coil. So relay coil is connected to the battery. And then here we put normally closed switch. Normally closed switch is connected to the lamp with Z. So like this. So this equation. So when we put the A, when you put the A here, the relays are attracted normally closed. So when A is closed, normally closed is attracted so that Z does not get the electricity. When A is open, relay release the normally closed contact. So normally closed contact will be closed gate and then we receive the electricity. This means that whenever you press the close the A switch, normally close is open and that will not get the electricity. Whenever you open the A switch, normally close is reclose and Z got the electricity. So this is a NOR gate function. So NOR gate function is a A1, the opposite to the output will be opposite to the input. After that, we also utilize the NAND gate. The NAND gate function is that we use the combination of the AND gate and the NOR gate combination. Use the AND gate here. This is A, B, and this one is the opposite. NAND gate is the opposite to the AND gate. AND gate function is A0, B0, Z0. But for the NAND gate, A0, B0, Z must be 1. And also for the A0, for the AND gate, A0, B1, Z0. But for the NAND gate, A0, B1, Z also 1. But only thing that for the AND gate, A1, B1, Z1. For the NAND gate, A1, B1, Z will be the 0. So this is for the totally opposite function. So we can draw a, B, and a Z. Okay, AND gate are A0, B0, Z0. And NAND gate A0, B0, Z1. AND gate A0, B1, Z0. But here is a Z1. AND gate A1, B0, Z0. Here is 1. And A1, B1, Z0. So this is the NAND gate function. So NAND gate function is we can also draw the NAND gate function. So this is a two-switch series is similar to AND gate. And this two-switch series is connected to relay. And this relays we energize normally closed contact. So then we connected here, this is what we call a battery. And connected to the LED. So this function. So this is for the NAND gate function. We construct the NAND gate. And after this, we also construct the NOR gate. NOR gate also opposite to the OR gate. OR gate means that A1, B0, Z1. But for the NOR gate, A1, B0, that should be 0. And A0 for the OR gate, A0, B1, Z1. But for the NOR gate, A0, B1, Z0. For the OR gate are A0, B0, Z0. But for the NOR gate, A0, B0, Z1. For the OR gate, A1, B1, Z0, Z1. But for NOR gate are A1, B1, that should be the 0. So this is for the NOR gate function. So NOR gate function is a combination of the OR gate and the NOR gate. So this is the NOR gate. So this is combination of OR gate. So this is AB and combined with the NOR gate. So this is Z. So this is you can make the whole diagram here. This is the NOR gate function. So A, B, and the Z. 0, 0, 1, 0, 1, 0, 1, 0, 0, and 1, 1 is 0. So this is the truth table. So this one is a diagram. We can also draw a circuit diagram. So then, the N function is a two-switch in series. O function is two-switch in parallel. Two-switch in parallel is also connected to the relay. So this is for the NOR gate function. So this is A, B. So we connect the relay here. And this one is connected to the normally closed contact switch. And then this is connected to the LED. So that one is connected to the battery. So this is for the NOR gate function. Okay, finally we can see the H0 gate. H0 is the exclusive OR. This is the special diagram. H0 gate is similar to the everything the same as the OR gate, but it is only different. For the OR gate is for the A1, B1, that is 1. But H0 gate, A1, B1, that will be 0. The only the difference. So H0 gate is similar to the OR gate. So A, B, and the Z truth table. A0, B0, Z0, 1, 0, 1, 0, 1, also 1. Such a 1, 1, that will be 0. For the OR gate A1, B1, Z1, but H0 gate is A1, B1, Z0. So we can draw the H0 gate diagram like this. So this is for the A, this is B, this is Z. So those are the basic principle of the digital logic gate. So we utilize the digital logic gate to perform the function. So we use control function. We utilize the digital logic to activate the control function. Okay, so now that we also see the IC number. This is for the priori principle. But in the practically, you need to select the appropriate IC. Appropriate IC to perform the OR gate, OR function, AND function, NAND function, NOR function, exclusive OR function. So now I give you the list of the IC number. Okay, firstly you can choose the then we can CMOS. So this is for the K type. Type of the K, and we can use for the CMOS IC and TTL IC. For the K type is used for the AND gate. CMOS you can use the 4081. TTL is used as 7408. This is for the AND gate. And OR gate function, CMOS you can use as 4071. TTL you can use as 7432. And also the NAND. So there are other functions here. NAND is you can utilize as input function. So there we use depending on the number of input, you can use the 4011, 4023, 4012, 4068. For the TTL, you can utilize the 7400, 7410, 7420, 7430. So this is that kind of, and also you can utilize the NOR gate. So NOR gate you can use that 4001. CMOS are using 4001, but for the TTL use 7402. H0 gate function. So H0 gate function is exclusive OR gate. Exclusive OR gate you can use 4070, and in this case you can use 7486. And also H0 gate. Exclusive NOR gate we can utilize 4077. And this one you got 9386. So those are the ICs applicable to construct the AND function, OR function, NAND function, NOR function, and also the H0 function. And also that we also utilize for the NOR function. NOR function is this is inverter. Inverter is a NOR gate. NOR gate is we utilize the 4069 and 7404. So then I also put the NOR function. This is NOR. Okay, I put here K, CMOS, and TTL. So we use a NOR inverter. So NOR function, CMOS IC is a 4069, TTL IC will be a 7404. So those are the IC requirements. So when depend on the function you have to select the appropriate IC. So that those are the function and the appropriate IC to select. So those are two different operations of the digital system. So in the digital signal processing system, we use the number of gates to combine the number of gates to construct the required function. This is a Boolean algebra. So we use one of the AND gate. AND gate function is this is the ABC. A, B, and C. So output Z is equal to A multiplied B multiplied C. So this is for the Boolean algebra. So AND gate is similar to multiply function. And then we also utilize the OR gate. OR function is the output will be A, B, C is input. Output Z is equal to A plus B plus C. And also the NOR gate. So NOR gate is this gate here. When you put the input A, output will be the A bar. And also in this case you can also utilize the NAND gate. NAND gate. NAND gate means that input is a multiply. Output is a multiply of the input function. So input is A, B, C, supply. Output Z is equal to the A multiplying B multiplying C bar. So this is called a NAND gate. And also we can utilize for this NOR gate. NOR gate function is input is here A, B, C. Output is A plus B plus C and bar A plus B plus C bar. So this is for the NOR gate function. So OR gate, NOR gate, NAND gate we can represent by this way. Then we also utilize the Boolean postulate. Postulate means you have to remember start the formula to utilize Boolean postulate. This means that when you add a 0 multiply 0 is 0. 1 plus 1 is 1. 0 plus 0 is ever 0. 1 multiply 1 is 1. 1 multiply 0 is a 0 multiply 1 is equal to 0. And similarly, 1 plus 0 is 0 plus 1 is also equal to 1. And then we also utilize the A function. A plus 0 is A. A multiplying 0 is 0. A plus 1 is ever 1. A plus A is ever A. And A multiply A is also A. A plus A bar is equal to 1. A and A bar is equal to 0. So this is for the postulate. You can also write A plus B is equal to B plus A. And similarly, the A bar, another bar is similar to A. And A multiply B is equal to B multiply A. So those are the Boolean postulates. The Boolean postulates we can utilize to simplify the logic gate. So sometimes many logic gate here. We use the Boolean postulates to simplify and determine the appropriate logic gate. So this is we use we can construct a gate. Instead of constructing the 2 or 3 gates, you can simplify to the 1 gate by using the Boolean postulate. And similar to also we talk about the De Morgan theorem. De Morgan theorem is the combination can be changed to the addition. Addition and the multiplication can be the changes. So this is for the De Morgan theorem. So I don't need to go through that detailedly because those are in the digital electronics. I just give you the general overview of theory. Another one we use the De Morgan theorem. So De Morgan theorem means we use the logic gate for the simplify. So De Morgan theorem is that A plus B is equal to A multiply B, A bar multiply B bar, and the whole bar. So this is called the De Morgan theorem. So we can change the formula by this way. This is called the De Morgan theorem. And similarly, we can also use the equation A bar plus B bar. So A plus B, A multiply B, A dot B plus dot C plus D. So this equation is equal to the A bar plus B bar, a bracket plus C plus D bar, and the whole bar. So this is for we use the De Morgan theorem. So based on the De Morgan theorem and the Boolean algebra, we can find the appropriate gate. Sometimes we want the NOR gate, but we don't have the NOR gate. Only we got a NAND gate. So in this case, you should be able to utilize the NAND gate to get the NOR function. In the meantime, sometimes you want an AND function, but you only got a NAND gate. So you should be able to connect the NAND gate to get the AND function. So now I give you the equivalent case table. Equivalent gate table means I got only NAND gate. I got only NAND gate and NOR gate. I want to construct a NOR gate, AND gate, OR gate, XOR gate. So I give you the equivalent combination of the NAND gate to get the require function. So those functions are driven by applying the Boolean algebra and the De Morgan theorem. We use the De Morgan theorem and the Boolean postulate. So those are the equations. So this is the Boolean postulate means that n gate, or gate, NAND gate, we get that the function can be written by the mathematical equation. De Morgan theorem means that addition can be the change to the multiplication. So the function is why we use the those things. Sometimes we can't get the exact gate. For example, we want that NOR gate, but you only get a NAND gate and NOR gate. So this is the equivalent diagram. By connecting the NAND gate and NOR gate by this way, you can construct the NOR gate, AND gate, OR gate, NAND gate, and the NOR gate. So this is the why that we use the Boolean algebra. So Boolean algebra and the De Morgan theorem we utilize to try the equivalence and combination of the logic gate. If you can't get the IC, for example, you only got the 7400 IC. Okay, you got only 7400 IC. 7400 IC only you can construct the NAND gate. The NAND gates are most of the IC you can get for the NAND gate. So they are more widely available. But you can find the 7408 or 7432 to construct the AND OR gate. So it doesn't matter. You still use the NAND gate and then make that connection like this, and you can get the other gate. This is why we do the De Morgan theorem. So this is, but I don't go detailedly about the De Morgan. I just tell you that why we utilize those theorems. Number system. Binary number system means that we use base 10, base 2, base 16. So base 10 means a decimal system, base 2 means a binary system, and base 16 means a hash decimal system. More details I will be in the digital signal processing. Now that I just give you the equivalent circuit, the physical circuit to construct the binary number system. Most of binary number system will be belong to the digital signal processing. So it will be starting from the V6. So now V4 and V5 are in that going through the digital theory. So the digital theory. So in this case, we need to construct the adder circuit. So two numbers need to be added. So this is the adder circuit. So adder can be the half adder and the full adder. So when you combine the two numbers, sometimes you have to carry on. Carry on means that, for example, 9 plus 1. 9 plus 1 is 10. 10 says 9 plus 1 direct combination, you got a 0 and a 1 carry. So this carry function can be performed by the adder circuit. So I give you the adder circuit. So adder circuit means the two numbers are adding, two binary numbers adding, we construct the adder circuit. So adder circuit you can utilize by the XOR gate. XOR gate, we use the adder because XOR gate function is when the A is 1B1, so A plus B is 0 because the XOR gate function. XOR gate is similar to the equivalent of the OR gate. Yeah. So XOR gate function is when you make the A0 B0 is a B1, and also A1 A0 B0 is a Z0. A1 B0 is Z1, A0 B1 is Z1, but A1 B1 is Z0. This means that find this one only 0. This is similar to the carry function. So this one is carried to somewhere, so this is called similar to XOR gate. So XOR gate, because based on its principle, we utilize the XOR gate to construct the adder circuit. So adder circuit, we can use the XOR gate. In the industrial control system, we use the digital circuit. Digital circuit to construct the industrial control system. So then we use AND gate, OR gate, NOR gate, NAND gate. So those are the appropriate IC to form the those gate. And this is for the mathematical equation. This is for the equivalent gate. Now we are talking about the adder circuit. Adder circuit is we use it. This is the XOR gate. It's the exclusive OR gate. Why you use the XOR gate? You see the XOR gate truth there. 1 1 is a 0. So the similar to that function. 9 plus 1 is a 1 0. So 10. So this is a 10 is a carry. So 0 is a direct function. So this function is similar to the XOR gate. This is why we use the XOR gate to construct the adder circuit. So adder can be the full header and the half header. So I now give you the half header. Half header circuit means we apply the H0K and gate combination to get the half header circuit. So now I give you the half header. Half header is combination of the this is A here and this is B. So these two lines. So A line is similar to the H. This is called the sum. So this one will be and gate. So this will be the carry out. So we consider the sum is the H0K and gate to make the carry out. Carry out is that we use the and gate. So now we can start drawing the truth table. The truth table means A, B, sum, and the carry. So where A put the 0, B0, sign 0, carry 0. A0, B1, sign 1, carry stay 0. A1, B0, sign is 1, carry 0. And the A1, B1, sign will be 0 and carry will be 1. So this is for the function of the H0K application, truth table. Truth table, we use the H0K and the gate combination to form the truth table. So in this case, this half header circuit. Half header circuit is a combination of the H0K and gate. So those combination can be represented by a single diagram symbol. So this is for the input A, B. So there will be half header. Output is one time coming out as a sum, another coming out as a carry. So this is for the half header circuit. So half header circuit you can physically construct. You need the H0K IC and the gate IC. Gate IC you can use a 7408. H0K finally 7486. So you combine the 706 and 786 by according to this diagram, and then you can construct the half header circuit. And full header is two half header. Two half header combined with the OR gate. So then you got the full header. So that we can also draw that this is a half header and a full header. So full header circuit is there are two circuits here. There will be half header, and these ones are coming from A, B, and this is the sum, and this is CO. CO means carry. In this case, sum is you can use one as S, carry means CO, carry out in a CO. So A, B means 2 input. So this one is you can put this one as a sum, and this one is carry out. Okay, another half header we can also construct. So this is A, B. So this is a sum, and this is a CO coming out. So this CO and this CO make a combination, and this one is connected to the OR gate, and this will become a carry out. So this is for the half header. Two half headers are made combination. Half header and another half header. Okay, so this is for the, by this way you can call it full header. So this full header is this is for the schematic diagram. We can also draw it the physical diagram. Physical diagram means that this is half header. This is the H0K and the gate combination. This is the H0K and gate combination. The two things have to be combined. So now I give you the circuit. So this is for the H0K, and this is the gate combination. So this one we did this thing is another half header. So this one is coming out as a sum. So this combination. Another also that we can also construct the H0K and the gate combination. This is H0K here. And this is also gate. one also A, this is a B. And this one it says we get the carry in. Carry in, so this is called half error. So this one is combination. We connect to this carry out. So this is all carry out. So this is the one half error and another half error circuit. So this is a half error. So this is for the equivalent circuit diagram for the full error circuit. Full error circuit you use it as two half error, we wire this way, and this is a OR gate and make the carry out. So in the mathematical combination. Mathematical combination means all the mathematical functions are all the addition functions are executed by the half error and the full error circuit by this way. So in this case you can physically construct. You need a H0 gate. H0 gate means that you need a 7486 IT, and AND gate you need a 7408 function, and OR gate you need a 7430 IP. So IP you make combination by constructing you can determine the output are require some mathematical function. So those things are then utilized in the process control system, especially the standard process needs combination, so function, those are executed by those treated as logic gate. Yeah? So we use the digital logic gate means that AND gate function, both of the A and B must be present to get the output function. So this is for the AND gate. AND gate function is Z equal to A multiplied B multiplied C. The arithmetic function can be constructed by the AND gate. And for the addition function, Z equal to A plus B plus C. So this is a mathematical function you get acquired by the OR gate. NOR gate means a minus function. A is a positive, so output will be the negative. So this is for the NOR gate function. So A is equal to the NOR, after passing through the NOR gate, A becomes a bar. And NAND gate means that all the AND gates are multiplied opposite. So the A multiplied B multiplied C and the opposite one, that will be the Z. NOR gate means A plus B plus C bar. So A plus B plus C bar means the opposite function. When the A0, input 0, output 1, this is the opposite function. So we can utilize the NOR gate by this way. And Boolean postulator, this is the mathematical relationship for the digital gate. So 0 multiplied 0 is 0, 1 plus 1 is 1, 0 plus 0 is a 0, 1 multiplied 1 is 1. 1 and 0 multiplied is equal to 0 and 1. So similarly, the A plus 0 is A multiplied 0 is 0, A plus 1 is 1, A plus A multiplied A also the A and the A opposite bar is equal to 1, A and the A bar is equal to 0. And we also utilize as a De Morgan theorem. De Morgan theorem means that addition can be the chain as a multiplication by using the De Morgan theorem. For example, A plus B is equal to A bar dot B bar and the whole bar. So this is for the De Morgan theorem. Why we use the De Morgan theorem? Sometimes we can't get the equivalent gate. For example, to construct the AND gate, you need the 7408 TTS. Or gate you need a 7432, but you don't have any more IC, only one, you got it a NAND gate. NAND gate that you only got a 7400 IC. So you only got a NAND gate IC, you want to construct a NOR gate, so you have to utilize this table. This table, all NAND gates are made combination, and you can find as a NOR gate, AND gate, OR gate, NAND gate, NOR gate. So how to get it? We apply the De Morgan theorem, make the mathematical calculation, design, and we can construct the appropriate gate. So those are De Morgan theorem is only utilized to summarize or simplify the logic gate. And now that we use the error circuit. Error circuit means that two numbers are adding, so should be the digital circuit should be executed numerical calculation. For example, you want to add the A and B addition. So A and B additions we use the H0 gate function. The reason is when you numerically add the 9 and 1, then we 10 you got. 10 is really the 0 is a real addition, real sum, and 1 is a carry. And so you see that H0 gate the function. So A0 B0 output is A plus B0, A0 B1 output 1, A1 B0 0 1, and A11 is a 0. So this 0 is similar to the sum. So this is the H or K that you can utilize as a function. So when you are using the addition circuit, you need the two divided. H or K for the sum and J for the carry out. So this is the equivalent circuit diagram and truth data here. So the AB, A plus B, you add, so sum is a 0, carry is 0. A1, B1, and sum 0 and the carry 1. So this is the half error circuit. So half error circuit only suitable for the two binary bits. But it does not allow for the carry from the previous addition. So in this case, you want to add the 4 bits of binary number, you need to add the two full error circuit. Full error circuit means that two half error, you make the combination by this way. So there are two half error 1, half error 2, they make combination by OR gate. So this one is coming out as a sum, this one coming out as a carry out. So carry in means the previous state. When you make the many K, so one state make carry can go to the another one. So like I say, you get add many number. So that this is the digit that two tables for the full error circuit. So full error circuit, you make the addition. Addition means that all the number you addition. So many number you add, so you can use the Mozart gate. So in here now you use the 32-bit system, 64-bit system. In this case, you use the many adder IC combination to make the carry. So three products we can use only one state, but in reality, there are many numbers to be added. So in this case, you have to make the cascade circuit. Cascade circuit means that we use all the full adder. Full adder, the whole thing is a full adder. So full adder, you can draw a circuit. This is the half adder. Two half adder combination. Two half adder combination means full adder you can draw a equivalent circuit diagram. How many terminals are coming out? Input way is 3 terminals, carry in, AB, and output way is sum and carry out. So this means that full adder you can draw the equivalent circuit like this. So that way we can carry in, C in. C in is a carry in, and this is the A number and the B number. The output way is a sum, S number, and the carry out, CO. C in is a carry in. Carry in that you can find as a C in. C is a carry in. And CO means a carry out. S means a sum. So that way full error. So this is a full error circuit. Full error circuit means input is a carry in AB and the output means the sum and the carry out. So now this full error circuit we utilize. We utilize the full error circuit to process cascading. Cascading means that you will need to add the 4-bit binary number. So now I will make this a cascading circuit. So there will be the full error. The first error is this coming out of C in. So C in is connected to ground. And this is for the we start from the A0 and the B0. And output will be the F0 is coming out. And this is C0 coming here. Another full error, there will be C in and a C out. So this one is a A1 and a B1. So this carry is connected here, C out is connected like this. And another error, so this is a C in and a C out. So this C out is connected to this C in. And then we connected to this A2 and B2. So this is the A2 and this is B2. So this is the out coming connected like this. So another error circuit. So then we use the C in. So then we see in here and C out. So then we use that this is a A3 and a B3. So output will be the S3 and the CO3. So this is also the S2 and this is the S1. So this is for the full error. So this is for the full error. So output line input numbers are to the 9 marks, so this is a sum and carry out. So output is a 4 bits two 4-bit binary numbers will be coming out. So this is for the we construct that is a digital construction. We use the row error circuit by the way to produce the output. This is the principle. So we start, I review the digital gate and they are punching the equivalent diagram. So we IT to be utilized, and then I also start with the error circuit. And then also through the digital course included number system. So number systems I will be teaching in the week system for the digital signal processing. So now I just bypass this portion and I go to the decoder and encoder. And in the details of digital course, you can also see that internet circuit connection for the DGL and open for the logic. So those are internet equivalent diode and transistor equivalent circuit diagram. So but those are belong to the digital course. So I only teaching the digital for the signal processing to be utilized for the industrial control system. So now I'm talking about the encoder and the decoder. Encoder and decoder function means there will be the input function will be the analog function. So this analog function will be the variant function. This variant function needs to be transferred to the digital format. So therefore we have to utilize the encoder function. Encoder function means that any data within the digital circuit is comprised of the 1 and the 0. So this is for the in the digital circuit is only working on the 1 and 0. But output device may display the data in the various form. Various form means that data can be in the binary form or the octet or the hexadecimal form or decimal form. So this means that we need to use it and devices to convert the digital to the binary format or and then the binary format to convert to the decimal. So this is the things that we require the encoder and the decoder. Encoder function means that any decimal format can be transferred to the binary format, binary coded number format by using the encoder function. So now I give you the encoder function and the equivalent logic gate connection. So any data within the digital circuit is comprised of the 1 and 0. So this is in the digital system, only 1 and 0 is working. So all those input device may display the data in various form, such as the octet or hexadecimal form. Input can be decimal, hexadecimal. So in this case, when you use the keyboard to enter the data, you need to enter the decimal number. So in those device in the digital circuit, such as keyboard or digital transducer, we input the binary information in the form other than the straight binary. So this means that you might sometimes use the 100. So 100.1, this is for the decimal form. So this is not a binary form. For encoder and decoder is utilized to transfer those other format form to the digital form, binary form. So this is why we use the binary number. Encoder. So encoder is we utilize for the binary coded decimal, BCD. BCD is a binary coded decimal. Binary coded decimal. So this binary coded decimal, BCD is a silhouette to represent the all positive and negative function. So this is we use the binary coded decimal, BCD code. Binary coded decimal. So for example, you see that 2310. 2310 means 23 base 10. So this one is a BCD, is similar to 0010 and 0011. So how you check it? 23 means 2 and 3. So 23 is a 2. 2 that you divide. 2 is divided by 2. So this is a 1, 0. Then so this one is a 4 digit. 4 digit means this is you can put any other 0. So this is 2 cannot be divided by 1. So this is a 0, 0. So 2 is divided by 2. So this is 1, 0. So this is for you get a 1, 0. 1, 0 you put another 2, 0 to form a 4 digit. So this is a 0, 0. 1, 0 is a 2 and another 3 divided by 2. So this is the 1. So this is the remainder is 1. So this is the 1, 1. Okay, 1, 1. 1, 1 functions are for the 4 digits, you have to put another 2. So 0, 0, 1, 1. So this is for the 4 digits. Therefore, the 2 is the decimal 2 can be represented by the binary 0, 0, 1, 0. And the decimal 3 can be represented by the binary 0, 0, 1, 1. So 0, 0, 1, 0 for the 2 and 0, 0, 1, 1 for the 1. So this is for the BCD code. So we represent BCD code by this way. And similarly, 2, 5, 7, 9, binary 10. So 2 function you change the 0, 0, 1, 0. And 5 is a 0, 1, 0, 1. 7, 0, 1, 1, 1. And 9, 1, 0, 0, 1. So this is a BCD code. So we use the decimal 3, 23 to the BCD code 0010 and 0011. 27, 2579 is 0010, 0101, 0111, 1001. So this is for the BCD code. So because of this one, we can I give you the table to change the decimal to BCD. So decimal to BCD. So that this is a decimal number and this is a BCD. So 0 is a 0000, 1 is 0001, 2 0010, 3 0011, 4 0100, 5 0101, 6 0110, 7 0111, 8 1000, 9 1001. So this is the conversion between the BCD to decimal. So this is the status to the chain of the BCD to decimal system. And then now we utilize for the gray code. Gray code number is the same to the BCD. BCD function only end at a 9. So gray code we can utilize up to the 15. Up to 15. So this is we can use the gray code number. We use the sharp. This is the sharp here. And just for the schedule, this is for the this is the gray code is the segment. This is 1, 0, 2, 3, 4, 5, 6, 7, 8, 9 like this. So there are some are the coded, some are the not coded, so like this. For example, this is just an example. So this way is this is the revolving. The revolving piece you send a pin. So our electric pins are sent to the revolving. So sound like when another piece is revolving. So the pins are cut as continuous data. Continuous data to output with the decimal format. So by this way you can change the analog digital. So this is called a continuous like. And this one is the decimal function line. So free will be rotating. Free rotation. And this is the decimal code. This is for the primary code. So this is binary codec. So binary codecs are this began at here is the analog function, continuous analog. And here will be the digital function. So this way, so all the time how we construct means that we need the auto transducer. Transducer means the electrical function. We use the auto electricity. Auto electricity means the input is a continuous voltage. So that this pins are produced as rays. So these rays are passing through this tree. So this tree is rotating. So that when this tree cuts data, so output will be the binary coded data coming out. So this is for we can construct analog to the digital conversion. So this is a gray code. Gray code means this one is a continuous data. You convert it to the digital. So we use a gray code number. So I also give you this gray code table. Decimal, binary, and the gray code table. If this is a gray code table, the output number will come out like this. So this is for the gray code number. So now this is for the decoder system. Decoder system means this decoder system we use as the wheel. The wheel you have to be driven by the motor. So input is a continuous signal. Continuous signal is produced by the transducer. Transducer means any speed or the speed provided through the voltage by using the tachometer, and this voltage ignite the light. So light is a glow based on the voltage. So this light beam may be the analog signal. So this light is a proportional to a speed. So this light signal is they are cutting by this gray code field. So output will use a digital signal coming out. So this is for the electromechanical devices. We utilize the electromechanical devices to convert the analog to digital. So this is the old times when the digital technology just introduced. We intensively use the electromechanical devices. Now today's electromechanical devices are replaced by the semiconductor. So now I give you the semiconductor device. So that decoder function can also be performed by the semiconductor. So that this semiconductor will combine the AND gate and NOR gate. By combining the AND gate and NOR gate function, you can construct the decoder. So this gray decoder function, the similar function can be constructed by the electronic circuit devices. So I give you this circuit device side. Before I'm going through the digital circuit, now I explain the difference between the decoder and the encoder. Decoder is defined as a device that has a number of input. So input is many number, but only only one output for the given input code. So this means that we can draw the decoder circuit. So this is a decoder circuit here. Input will be other switch. So many switch. So output is also this is a 0, 1, 2, 3 like this. So this is for the output. So this is the input. So although we got many input, we don't need many input. We only select the switch. So you need to select the switch. Doesn't mean that you need to select for this one. You need to select, and then this one is connected to the join to the required output value. So this is the select switch, and you can this is the selector. So this means that only one output for given input code. So when you select this one, and this point you put this position, so this one goes to the 0. And you select this one, for example, this is the ABC. When you select the A, and you allocate the connection to 0, so this means input A goes to the 0. And then you select the A, this point are connected to 1, so that from input A goes to 1. So this is only one, although they are separate input, at the one time, only one input is channeled to the output. So this is for the decoder function. Decoder is defined as a device. There is a number of inputs and outputs, but at the base only one output for a given input code. So for a given input code, you can only connect it to the one output. So this is for the decoder function. In encoder is the difference. Encoder has a number of input and output, but produce specific code at the output where only one input at the time is activated. So this means that this is the input here. Input function is. So for example, 0, 1, 2, 3, and up to the 9. So this is the input. So you have to input the input. The output will be this output is here you get multiply 2 power 3. So this is the output. And this one is multiply 2 power 2. So here multiply 2 power 1. Multiply 2 power 0. So this is the BCD output. Okay, so For example, you put the input 1011. So this one you put the input code 1011. This is the input. So how will you use the output? The output will be 1 multiplied by 2 power 3 plus 0 multiplied by 2 power 2 plus 1 multiplied by 2 power 1 plus 1 multiplied by 2 power 0. Then you got the output. So that will be the 8 plus 0 plus 2 plus 1. So that will be 11. You have to put the input 1011, output is coming out 11. This function is the encoder function. Encoder function means you have to, all the input can be simultaneously. You can put the input any number, but depending on the input number, the output coming out. So this is called as this function is similar to the parallel function. And decoder is only the serial function. Serial function means that if you connect one for the input A, then this is the output to the connect to 0, so A go to 0. And when you put the input is B, output to the go to the connect to 2, so B go to 2. So this function is a serial function. So serial function and the parallel functions are utilized in the digital control system. So parallel function, you see that in the digital computer system, you see the bus. So that bus to the parallel bus, all data can be simultaneously transferred. Serial means the sequential. Sequential means the sequential control system. We use the serial function. So this may mean that when the timer control or sequential control, we have to utilize the decoder function to perform the sequential function. But the simultaneous data transfer, you have to utilize the encoder function. So this is the difference between encoder and decoder. So both encoder and decoder function can also be controlled by the digital circuit. Now I give you the digital circuit. This circuit will include the AND gate and the NOR gate. So AND gate is I already give you the IC, and NOR gate I also give you the IC. Through IC you make the wire and you can control the decoder circuit. So now I give you the decoder circuit diagram. Okay. It was only A and B. So we use the NOR gate. Two NOR gate we connected. So this one with the A bar, B bar. And this one is the input is the A bar B, A B bar, and AD. So output is the 0, 1, 2, 3. So 3 output. So this is a decoder function. So this decoder function, the perform this function. So this is we utilize the digital circuit to perform the decoder function. So after this is today's I talk about the digital signal processing. So I give you the basic digital theory. I review about the digital logic gate, their IC construction, and the Boolean algebra, and then I talk about how to make the decoder function, encoder function. So and the equivalent logic gate construction diagram. So then I talk about. And next video I will talk about the multiplexer, demultiplexer, and also the flip-flop. Flip-flop means memory. We can remember recognize the memory. So and then the output will depend on the memorize. Multiplexer means the input one function, output will use the doublet function. So this is the multiplexer we utilize. And flip-flop function is the flip-flop can memorize the sequence of the operation. So there will be the RJ, flip-flop, DJ, flip-flop, master flip-flop. So those things I will give you. And then I will give you the shift register and the latch. Shift register and latch, this is where you utilize for the data transfer and counter, principal counter. So there will be the reads 5 and 6 we do. And after that I start the digital signal processing. So this is why we use in the industrial